gel. So take a look on the first Agarose gel. You kind of see this, like we're talking kind of see this. Hold on 1 second. Okay, so we're going to see for sure nicked, linear, and supercoiled DNA. The circular single-stranded is actually what happens when you leave it on a kit for too long and it pretty much goes back into its circular shape. It's actually something you don't want to see. So if you see a circular band, we have a problem, okay? It's not good at all.
Wait, so what's the bottom? Like, see
the circular?
Not in the picture.
Oh, in the picture, that should be, so that bottom one should be your, let's see, I'm looking at the positive control. So the positive control, which is on the left-hand side, so that bottom band is just extra stuff.
Oh.
So those are things that we just weren't able to pull because I didn't run it off the gel. If you guys remember, I went 3/4 of the gel. So that's just extra stuff. That could be some of your circular single-stranded DNA as well. But more than likely, it's something else. But where you're looking is, you see on the, okay, so second lane, you see that really dark marker for the molecular weight. So right above it, on the left, is that positive control. So I put the positive control on the left, and we can actually see those 3 bands if you kind of zoom it up. So right here, 1, 2, 3. Right here, 1, 2, 3. Right here, 1, 2, 3. Yeah. This one is acrylamide. The acrylamide, sorry.
Yeah.
Sorry, you can see it on the acrylamide.
Not the other band.
You can see it on the 1, 2, 3 on the acrylamide.
I now see the 3 bands.
Yes. Sorry,
No.
they're done. And then for the Agarose, if you really blow it up, and I mean really blow it up, you can kind of start seeing some of the other parts of the bands. It's kind of very blurry, this guy, for your Agarose. So you should see some nicked DNA. Can anyone tell me what the nicked DNA is? It's kind of self-explanatory, right? It's nicked, right? It's in fragments. Now, is your nicked DNA going to be faster or slower on your gel? Slower, okay? So what does it tell us about its molecular weight? Should it be higher or lower than our circular singular stranded DNA? Great job. So we want to make sure we understand how our gels are working. Then we have our linear DNA, and then what we're after is the supercoiled DNA. So it's really important to make sure we see where our supercoiled DNA is. Again, on the Agarose gel, it's really hard to see. But on the acrylamide, it's going to be that band, that lower band that we do see. Now, one thing I really want you guys to look at and to talk about in your discussion for this report is I want you to identify around the area where you think the nicked linear supercoiled is for your sample, okay? So make sure you label your gels, the markers. Did everyone take a picture of that sheet? Found out the other section, a couple of them didn't. So did one of them email you about that?
That's fine.
Okay.
Do we label everybody's or just ours?
No, just your own.
Just your own, yeah. So I want you to label marker, and then you need to identify where your negative and your positive control is, and then just start discussing what you see, okay? That's the point of this experiment, is to really see what the difference between an Agarose gel is and what the difference between an acrylamide gel is. You guys talked about it in your intros, and the biggest part is their size range, right? What was the size range for acrylamide? For all of you.
Acrylamide, it was the smaller size, so it was, I remember, I had it somewhere.
You might be tested
The
on that.
highest was like 800
It was around there.
The lowest, it was around, I don't know, probably was around 50, like 800,
Okay.
around that kind of size.
Anyone else have for agarose and acrylamide? You guys have computers, did you not email it to you guys? Come on.
Are you asking what size range they separate best at?
Yes, thank you.
Oh. Polyacrylamide 10 to 800 nucleotide bases, and then agarose is 300 to 50,000.
There we go.
800.
Yes. Great job. So it's really important to know the differences between the different types of gels and why you use them, okay? Because when you work in industry, they're gonna tell you, okay, we'll run it on the gel. How many different gels have you guys worked with in this course? 3 technically, right? Because we had the SDS type, where it had stacking, right? And then we had the special type where we didn't have the 2 layers for our acrylamide, and then we have our agarose gel. Agarose gel we actually use more after we run a PCR sample. Agarose gels also we're able to slice out our DNA, our proteins, our vectors out of them, and we melt the gels, and we're able to grab the proteins or the DNA or whatever we're grabbing out of them, and we're able to actually get a pure amount of those samples, okay? So a lot of biochemists do use agarose gels. I used them a lot. We actually had a big bin of them, which is so much fun. But they, of course, have ethylene bromide in them, so you can't play with them afterwards. Unlike the acrylamide gels, pretty much you can put those in your planters. They're really great to keep your plants alive because they absorb water really good. So have you ever seen those little jelly beads? That's acrylamide. Fun facts.
Ready for me?
Yep.
Okay. Get the